Today I will be presenting you about my computer networks project that I have done in this semester. This project has been done by me, Manmeet Singh, and my group mate Varun. The topic of this project is small scale model of the internet. So here it goes. So the code has been written in MATLAB. So the code has been divided into three parts. This is the main function. The other function is the Dijkstra's algorithm, and the other function is the CSMA CD scheme. So Dijkstra algorithm is used when the communication is between two buses which are the Dijkstra algorithm is used when the communication is done between nodes which are on two different buses. CSMA CD scheme is used when the communication is done between two nodes on the same bus. So let us run this code. The code takes 30 seconds to simulate. That is, for 30 seconds each and every node will generate packet and transmit to each and every node in its network, and after 30 seconds of simulation we will get an output. So let's just wait for 30 seconds. Yeah, so after 30 seconds we get an output of these 24 figures. I will come to these figures afterwards. Let us first see the command window. So this is the command window. So this is the part 3 of the simulation that I have given my code. So the first packet is sent from source 1 to destination 1, that is from itself to itself. This has been done to show the correct implementation of Dijkstra, that as it is one of the edge cases. So the cost is 0 and the path taken is 1. So this is the cost matrix. When the source is 1 and destination is 2, then CSMA CD scheme is used and no Dijkstra algorithm is used. So it gives stats about total packets in average frame interval, queue delay, end-to-end throughput. When source is 1 and destination is 3, then Dijkstra's algorithm is used, and as we can see that the cost matrix gets updated. In the previous, the cost was 0045. In the next, the cost is 0069. So it gets updated frequently during the simulation of the project, as we can go through. And this is the path, that is from 1 to 3, as the minimum cost is 6, which is on the direct connection between 1 and 3. Similarly, for 1 and 4, Dijkstra's algorithm is used. This project simulates each and every node. Hence, in the output window we can see every node sending packets to itself and each other node in the network, and the working is similar using CSMA CD and Dijkstra's algorithm. Now let's come to the plots. These plots has been done in order to show the stats. So these plots, there are 24 of these plots which have been plotted for each source and destination node. So this is for 2 to 1 packets, the source is 2 and the destination is 1. So we have got queue delay, access delay, frame node, and this is for 3 and 4, that is the source is 3 and destination is 4. So the frame interval and the number of frames in between 3 and 4 and 4 and 3. Similarly we got for 1 2 1 3 1 4, etc. So this was the basic working of Dijkstra's and CSMA CD. Now let's look into go backend algorithm that I have been implemented to show you how ARQ basically works. So in this code I have given a privilege to user to enter the window size, and by entering the window size we can calculate the range of sequence number. Let us run this code. Command window, the size entered is 3. The sequence number range from 1 to 7, as we know that the maximum sequence number can be 2 raised to power size of window minus 1. So this basically shows the working of go backend. Whenever there is a transmission, only 3 frames can be transmitted as the size of window is 3, and when there is a loss, receiver discards all the packet after it. Sender has to transmit all the packets from the packet that has been lost and every packet that it has sent again. So this was basic functioning of go backend. Now I have also implemented a graphical user interface or GUI to plot the statistics. So this is the GUI library of MATLAB that I have implemented in order to use the GUI. Let us just run this code. The code is running and this is the GUI interface. Those plots will be plotted in these areas, and this is the simulate button. This will show the cost matrix, this will show the cost, and this will show the path. Let's simulate it, and after some simulation time we get the minimum cost. This is the cost, this is the path, and this is the cost matrix. And similarly, after some time we will get for another node as the cost updated, and these are the paths. And this is the project that I have implemented. Thank you so much.